So here's your guys' lecture, March 19th of graphing inverse functions. Now remember guys, this is the last new lesson and then it's just reviewing for the quiz, okay? So here we go. So this is graphing inverse functions and we're gonna write this down, okay? So here's a function f of x is equal to 1/2 x plus 2. Let's look at graphing this function using xy table and then graphing its inverse. So that's the original function, you guys, and we are going to be graphing the original first and then graphing its inverse from the original. Okay, so next, you guys, we have, I just rewrote it and I'll show you guys how to do this. Alright, so this is our original function, and now we want to just plug in points to solve for this. So I just chose the even ones, you guys, because if you plug in even numbers into here, you can take half of even numbers. So if you guys plug in 4 into this equation, 4 times 1/2 is 4 over 2, and 4 divided by 2 is 2, so this would be 2 plus 2, which is 4. If you guys plug in 2 into the equation, it's going to be 2 times 1/2, which is 1, 1 plus 2, 3. If you guys plug in 0, that's just going to be 2. If you guys plug in -2, it's going to be -2 times 1/2, which is -1, -1 plus 2, 1. And if you guys plug in -4, it's going to give you -2. So -2 plus 2 is 0. So that is our points, and now let's plot those. So we're going to get 4, 4, 1, 2, oh, different color. One, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So right there. 2, 3. 1, 2 to the right. 1, 2, 3 to the top. 0, 2. -2, 1, and -4, 0. So there's my graph, and I'm going to graph it. So then we get that. Okay, so that's the graph for the original. Now, here is just the inverse function. You'll have to solve for that later, but I just gave it to you. Now remember, now that we know the original function's coordinates, right? I'll erase this. Now that you guys know the original coordinates of the original function, to get the inverse coordinates, all you guys have to do is switch your x and y coordinates of the original. So then you guys get 4, 4, 3, 2, 2, 0, 1, -2, and 0, -4. So then we'll plot these. 4, 4, 3, 2, 2, 0, 1, -2, and 0, -4. And there's your guys' inverse graph. Now, let's talk about this, okay? So, when you guys take a look at these two graphs, is there a line that you can draw that will reflect one graph onto the other? So is there some imaginary line that you guys can draw that it will reflect one of the graphs onto the other? Well, if you guys take a look, it is exactly this line, this blue one, that it reflects it over. So usually we reflect over the x or y axis, you guys, that line is the y is equal to x line. And if you guys reflect over that blue line, the red would go on the purple and the purple graph would go on the red. So a function and its inverse reflect over y is equal to x, which is the blue line on the graph above. So if you guys were curious, like, you don't have to write this down, but do you guys recall, like, oh, f of g of x is equal to x, or g of f of x is equal to x? That's when you verify that they're inverses of each other, right? Well, the reason why they have to equal to x is because it's demonstrated when it reflects over the line y is equal to x. That's the reason why it has to equal x for that. Okay, so that's essentially what it means to reflect over the line y is equal to x, you guys. It's pretty much the inverse function of the original function. Alright, so below, here are the steps on how to graph inverses. Now remember, this applies to any type of function as long as it's invertible, but remember, with each type of new function, there are certain techniques you gotta do for each type of function in order to graph. So the first one, you gotta find the inverse of your original function. The second one, you find the points of the original function and then use an XY table to graph that. And then thirdly, you guys make your XY table of the inverse function by switching all of the XY coordinates of the original, and then you graph your inverse function. This is the technique on how you guys how do you guys graph your inverses. Alright, so we're gonna take a look at your guys' first example. And it's going to be a linear function. Okay, so find the inverse, and then you guys got to graph the function and its inverse. Okay, so here's your guys' original, so we have to go and find the inverse. So remember, you have to change f of x to become y, which we did. And then you have to switch your x and y variables, like so. And then here, you gotta solve for y. So subtract 3/2 to both sides. And then once you guys subtract 3/2 to both sides, I'll make it more clear here. So that's what it looks like when you guys subtract 3/2 from both sides. And now to get rid of this 1/2, you have to multiply both sides by the reciprocal, which is essentially just 2. So the 1/2 and the 2, they're going to cancel, so you're just going to have y. And then when you distribute the 2 in the inside, 2 times x is 2x. 2 times -3/2 is -3, because the 2 and the denominator 2, they cancel out. And then you isolate your y's, so then you change y to be f inverse. So we have our inverse function. Okay, so second step. Now, using your notes, right? Second step is you gotta find the points of the original. So our original's right here. So now we gotta plug our points in and to solve, right? So with linear functions, you guys could simply just plot 3 points, and that's pretty much good enough. So if you plug in -1 into that x, -1/2 plus 3/2, you guys, is 2/2, which would give you just 1. If you guys plug in 0, you're just gonna get 3/2, and 3/2, you guys, is equal to 1.5 around. And if you guys plug in 1 into x, 1 times 1/2 is 1/2. 1/2 plus 3/2, you guys, is 4/2. 4/2 is 2. So now we're going to go plot this. -1, 1. 0, 3/2, which is like 1.5. And 1, 2, which is that. And then we graph this. Right, so there's your original graph, and now let's go find the inverse. So once we find our coordinates right of the original, we can switch x and y coordinates in order to get the xy table of the inverse. So I simply just switched -1 for 1, 0 for 1.5, and 1 for 2, and like so, and then you guys can graph your inverse. 1, -1's right here. Remember 3/2 is 1.5, so 1.5, 0 is right there. And 2, 1 is right there. And there's your guys' graph. So for linear functions, you guys, it's gonna be like so. So these are more of the easier type, and then it gets ramped up when we do our rational functions. So just to give you guys some pointers when it comes to rational functions. So this is a rational function. The parent function for this, you guys, looks like this. So you're gonna have some type of horizontal asymptote and a vertical asymptote at the same time. So just keep that in mind. Alright, so when we graph this one, right, gotta find the inverse first. So first step is to change f of x to become y. Second step, you switch your x and y coordinates. Sorry, you switch your x and y variables, and then you solve for y. So then you have to subtract 1 to both sides. And then you guys get that. Now, here you guys have to cross multiply. So put that over 1 and cross multiply. So you guys are going to get 1 plus 2 times x minus 1 is equal to 1 times 1, which is just 1. So you guys got to distribute. So y times x is xy, y times -1 is -y, 2 times x is 2x, and 2 times -1 is -2. So then we have to get the y's to just be on one side, so we're going to be eliminating these by moving them over to this side. So let's add 2 to both sides, and then subtract 2x from both sides. So then we get like so. Now here, you guys, right, you have a y in both of those terms, so we're going to factor out a y from each term. So x, y divided by y would give you x, negative y divided by y would give you -1, and that's when you guys factor out your y. And then once you guys factor out the y, then to isolate the y, you just divide both sides by x minus 1. So then this is what your inverse function looks like, and we're going to change y to be f inverse of x, -2x plus 3 all over x minus 1. Alright, so that's the first step. Now we have the second step. So second step, right, we have to make our points. So this is the rule of thumb when you guys do this. Put the vertical asymptote right there. So you set this equal to 0, right? And that tells you what your vertical asymptote is. Put the vertical asymptote in the middle, okay? So if you put it in the middle, well, you already know that this is going to be undefined. Because if you guys plug in -2 into here, -2 plus 2 is 0, and you can't have 1 over 0. Now let's plug in -3. So if you guys plug in -3 into that original equation, you're going to get 1 over -1. 1 over -1 is -1. -1 plus 1 is 0. If you guys plug in -4 into here, that would be -4 plus 2, which is -2. 1 over -2 is -1/2. -1/2 plus 1, you guys, is just 1/2. Okay, now we're going to go on the other side. When you guys plug in -1 into here, -1 plus 2 is 1. 1 over 1, 1. 1 plus 1, 2. And if you guys plug in 0 into here, you're going to get 1/2 plus 1. And 1/2 plus 1, you guys, is just 3/2. But that's just 1.5. So we are going to plot these. So we're going to get -3, 0. Oh, that's -2, 0. 1, 2, -3, 0. -4, 1/2. And we're going to get -1, 2. And 0, 3/2. Now remember, there's a horizontal asymptote and a vertical asymptote based off of this, right? So when I take a look at this, I'm kind of like, alright, well, this is a line in between them, so this looks to be a good vertical asymptote, and this is the line in between the points for the horizontal asymptote. So make sure you guys draw for precision because it's very tight on when you guys see the asymptotes. But as you guys can see, those lines fit in and they don't cross any of the points, so then when you guys graph it, just go along the asymptotes. Now, if you want to do it for a more mathematical practice, vertical asymptote from here is -2. And the horizontal asymptote is here, which is just y is equal to 1 and x is equal to -2. Okay, now you guys have to graph the what's it called? Inverse function. So for the inverse function, here's our inverse function, right? Now if you want to make a more practical approach when you find your asymptote, this is vertical asymptote, set that equal to 0, so vertical asymptote is going to be at 1. Now recall, your guys' horizontal asymptote for this is going to be -2. The reason why is, remember, the highest degree in this one's 1, the highest degree of this one's 1, and remember, whenever the degrees are the same, you just look at the coefficients. So -2 over 1 is just -2. Again, if you graph really well, then you don't technically need to know that information. Okay. Now let's do the inverse of that. Now remember, you guys switch all of these coordinates to get the inverse, right? So we switch them. So we're going to have 1/2 -4, 0 -3. We'll talk about that one later. 2, -1, and 3/2, 0. Now this, you guys, is going to give us undefined because I know, remember, you put the vertical asymptote in the middle. And then from there you just venture off. So now let's graph this for precision. 1/2 -4, 1, 2, 3, 4 is right here. 0, -3 is right here. 2, -1 is right there. And 3/2, which is 1.5, you guys, is right there. So, based off these graphs, remember we need to find a vertical asymptote and horizontal. This looks to be the horizontal. And if you guys take a look, this line right here seems to be the vertical because it's in between them. And then you guys just use the asymptotes to help guide you graph these. And there's your guys' graph of the function and inverse. So definitely takes getting some practice too, but this is our first lecture of this experience, you guys. So take these to heart, and then I'll make your guys' homework video real soon, okay? Peace.